Okay. So, dear students, hope you are all doing good. So, next in the continuation, okay, we'll move on to the next topic. So, that is the important topic, virtual memory. So, let's see what is the meaning of virtual memory and how we are going to implement virtual memory. So, let's try to understand, note down the definition of the virtual memory. So, keep the heading virtual memory, keep the heading virtual memory. So, first, so I am having small question. Now, tell me, anybody seen virtual memory? Anybody seen virtual memory? कोई virtual memory को देखा है? Virtual memory को देखा है? Right? No. Okay, fine. So, virtual memory means what? It is virtual. Virtual means what? Does not really exist. Does not really exist. Okay. So, virtual memory does not really exist. Okay, just wait. Okay. So, virtual memory does not really exist, but part of secondary memory. Part of secondary memory is made as what? Virtual memory. Part of secondary memory is made as virtual memory. Right. So, okay. Now, don't worry, like what is the meaning of that? We'll discuss all that. So, I'm repeating once again. So, virtual memory does not really exist, but part of secondary memory is made as virtual memory. Now, I am asking the question to you. Okay, virtual memory does not really exist, but what you can do is you can see how much memory allocated as a virtual memory for your computer. You can see that value. मतलब कितना हार्ड डिस्क का कितना पार्ट वर्चुअल मेमोरी बनाया गया. How much memory of your hard disk is made as a virtual memory, so that you can see. Anybody seen virtual memory? कोई देखा है आपका लैपटॉप में कितना वर्चुअल मेमोरी एलोकेट हुआ? Anybody seen that? कोई देखा है? No. Many people did not seen. All are belongs to computer science background only. Very, very worst. Okay, everybody is having latest laptop, i7 laptop with 1 TB hard disk and all that, 8 GB RAM, but you don't know where is virtual memory, how much virtual memory declared for your computer. Really, really bad. Now understand here. So you can check, okay, how much, okay, memory is made as a virtual memory for your computer. आप देख सकते, okay. कैसे देखना? Okay, go to your my computer, like maybe in Windows 10 you can go to this PC or something like that. So go to my computer, go to properties, okay, my computer properties, and go to advanced properties. In the advanced properties there, okay, you can see there, okay, there is a parameter called virtual memory. You can click that. Okay, virtual memory को click कर सकते हो. If you click that, you can see how much memory is made as virtual memory. Remember, you can change that parameter also. Okay, a value को आप change भी कर सकते हो. Okay, in the below you have a okay button called set and save, something like that. Okay, आप set करके आप save कर सकते हो. If you restart computer, automatically saves will change. Okay, say whatever the saves you made that will be applied. So don't save. Okay, आप कुछ भी change मत करो. Change करे तो क्या होता है? Okay, I will explain that. Okay, उसका मतलब क्या होता है? We'll discuss all that. So, I am repeating, okay, all the points. Virtual memory does not really exist, but part of secondary memory is made as virtual memory. Okay, virtual memory, how much virtual memory declared for your computer, that you can see on your computer. So, how to see that? Go to my computer, properties, advanced properties, there you can see virtual memory. So, आप देख लो, अगर आप laptop में watch कर रहा है, okay, video, you can directly pause my video and just go there and see, okay, how much memory declared as virtual memory. So, let's see, okay, let's see the definition of virtual memory. So, note down the definition of virtual memory, note down. Virtual memory gives an illusion, virtual memory gives an illusion to the programmer. Virtual memory gives an illusion to the programmer that the programs of larger size than actual physical memory can be executed. Programs of larger size than actual physical memory can be executed. So, just note down the definition. मैं साइड हो जा रहा हूं, सो प्लीज कॉपी दैट. Please copy the definition. Okay. Now understand here. Okay. Let's see. Understand what's the definition. Okay. Meaning of the definition. Virtual memory gives an illusion. Illusion means what? False assumption, or is a false assumption or a false feeling to the programmer. That programs of larger size. Listen carefully. Okay, this is important. Programs of larger size than actual physical memory can be executed. Programs of larger size than actual physical memory can be executed. It means what? Okay, let us say your program size. Listen carefully. So let's say your program size is 8 kilowords and your main memory, okay, let's say PAS is 4 kilowords. Program size is 8 kilowords and PS is what? Okay, 4 kilowords. Now remember, you can execute, your program is having size of 8 kilowords and actual main memory is having how much? Only 4 kilowords. But remember, you can execute your 8 kilowords of your program on the main memory of how much here? 4 kilowords. You can execute 8 kilowords of your program on the main memory of 4 kilowords. So how that is actually possible? That is actually possible with the help of virtual memory. Is that clear for everyone? Okay, सच में आप 8 किलोवर्ट्स का प्रोग्राम साइज है. Okay, मेन मेमोरी कितना है? Only 4 किलोवर्ट्स है. You can still execute 8 kilowords of your program on the main memory of only 4 kilowords. How that is possible? That is possible with the help of virtual memory. So how virtual memory is implemented? Okay, no doubt. Next, virtual memory is implemented by using, continuation में लिखो, virtual memory is implemented by using demand paging. Virtual memory is implemented by using demand paging or okay, demand segmentation. Demand paging or demand segmentation. Virtual memory is implemented, no doubt. Virtual memory implemented by using demand paging or demand segmentation. So it means what? It means what? Okay, if you are using paging as a if you are using paging as a memory management technique, then you have to use demand paging to implement virtual memory. If you are using segmentation as a memory management technique, okay, then you have to use what? Demand segmentation to implement virtual memory. So it all depends on what type of memory management technique the operating system is following. Is that clear? अगर आप पेजिंग यूज कर रहे हैं तो डिमांड पेजिंग इंप्लीमेंट करना पड़ेगा टू इंप्लीमेंट वर्चुअल मेमोरी. अगर आप सेगमेंटेशन यूज कर रहे हैं, ओके, एज अ मेमोरी मैनेजमेंट टेक्निक, देन यू हैव टू यूज डिमांड सेगमेंटेशन टू इंप्लीमेंट वर्चुअल मेमोरी. So okay, so now look at here, practically used is okay, demand paging. So Windows, okay, whatever the computer you are using, laptop you are using, in our all operating system Windows, okay, practically we use the concept of demand paging to implement virtual memory. So practically we use what? Demand paging to implement concept of virtual memory. So what is the meaning of demand paging and how virtual memory is implemented by using demand paging? That concept we are going to study now. Is that clear? No doubt. Keep the heading demand paging. So let's see what is the meaning of demand paging and how that will be implemented. No doubt. Keep the heading demand paging. So keep the heading demand paging. Note down the definition. Loading the page. Definition लिखो. Loading the page into memory. Loading the page into memory on demand. Loading the page into memory on demand. On demand मतलब okay, listen here, brace this में लिखो, whenever whenever page fault occurs. Whenever page fault occurs is called as a demand paging. Is called as demand paging. Is that clear? So, I am repeating definition. Okay, demand paging means what? Loading the page into memory on demand. On demand means what? Whenever the page fault occurs. So, that is called as what? Okay, demand paging. So, what is the meaning of that? इसका मतलब क्या होता है? So, you will understand all the points in detail. Okay. So, before that, you need to copy the diagram. So, please copy the diagram here. Please copy the diagram. So, diagram is small only. Okay, no need to turn the page. Okay, कुछ लोग सोच रहे हैं. Okay, turn करना क्या? So, no need. Okay, so please copy the okay diagram. Okay, अच्छे से copy करो. Okay. So, please copy this diagram. मैं साइड हो जा रहा हूँ. ओके, जस्ट 5 सेकंड्स के लिए आप पास कर लो. प्लीज पास माय वीडियो एंड कॉपी केयरफुली. ओके, नाउ सो आई एम अज्यूमिंग ऑल ऑफ यू कॉपीड. ओके, अगर आप कॉपी नहीं करे तो पास करो. राइट, सो नो प्रॉब्लम. नाउ अंडरस्टैंड हियर. ओके, सो लिसन केयरफुली. पूरा ध्यान से सुनो अच्छे से मैं जो भी बताऊंगा. सो विद दिस कॉन्सेप्ट वी आर गोइंग टू मेक द प्रॉपर कंक्लूजन. ओके, अभी तक जो भी छोटा छोटा डाउट अगर आपको होगा, सो ऑल योर डाउट्स विल बी क्लैरिफाइड विद दिस कॉन्सेप्ट. सो ओके, इफ यू आर स्टिल हैविंग एनी डाउट्स, ओके, यू कैन मेल मी. राइट, सो नाउ अंडरस्टैंड हियर. ओके, now if you observe this diagram, okay, if you observe this diagram, carefully observe the diagram. So this diagram is actually already there in your notes. Exactly the same diagram, this is already there in your notes. So can you tell me where is this diagram? Okay, in the notes. Okay, right. So in the paging concept, is that clear? So in the paging concept, exactly the same diagram, okay, is there in the okay notes. Now remember, when I started the paging, when I told you the paging, I told you the two important things, that logical address will be okay greater to physical address. remember practically, I am saying practically logical address will be greater to physical address. Question में कुछ भी हो सकता है, कभी कभी equal भी हो सकता है, question में कभी कभी smaller भी हो सकता है. Question is question, right? Don't think with respect to practical aspect. So, okay, so I said that logical address will be greater to physical address in the paging. And next, second thing I said, CPU always generates a logical address. So, why it is like this? What is the reasons for this? Now we are going to understand, okay, those two things. Okay, understand here why logical address will be greater to physical address and why CPU generates logical address. So, we are going to, okay, understand all these points. Listen carefully. Now, what is the meaning of LEAS and PAS? Listen here. In the LEAS, you are having how many pages here? 8 pages. What is the size of LEAS? 8 kilohertz. In the PAS, you are having how many frames? 4 frames. What is the size of PAS here? 4 kilohertz. Now, remember, what is the meaning of LEAS? Okay, in all the diagrams, okay, we are writing LEAS, okay, in all the diagrams, okay, whatever we study in the paging and all that. What is the meaning of LEAS? LEAS means virtual memory. Or you say secondary memory. Part of secondary memory is weighted as a virtual memory. Remember, important only difference is, okay, virtual memory is part of secondary memory mein, but okay, but that particular secondary memory is fully in the control of operating system. Is that clear? That point you should remember. Okay, next. Now come back to this. What is the meaning of LEAS? The answer is not just say. Listen carefully. LEAS means the size of the process with respect to number of pages. Size of the process with respect to number of pages. Initially, all the pages will be in the virtual memory. Initially, all the pages will be in the virtual memory. Now, look at here. So, I am writing here. So, what is the meaning of LEAS? Okay, I am just writing here. LEAS is same as what? Process size. Okay, you can just think of this. Is that clear? LEAS means what? Size of the process. Okay, size of the process with respect to number of pages. Now, tell me LEAS, a process having how many pages here? 8 pages. 0 to 7. 0 to 7, 8 pages are there. Initially, all the pages will be in the virtual memory. Or you say secondary memory. Okay, virtual memory. Is that clear for this point is clear for everyone? Right? So, I am repeating. In all the diagrams, whatever we studied, we have written the LEAS. What is the meaning of that? LEAS means the size of the process with respect to number of pages. Remember, initially all the pages will be in the virtual memory. Initially all the pages will be in the virtual memory. Now, that is the first point. And the next point. Now, come to the PAS. What is the meaning of PAS? PAS means the actual main memory allocated to the process. Actual main memory allocated to the processor. Is that clear? It means how much memory allocated to the process here? Okay, that is 4 frames. It means what? 4 kilohertz. Okay, something like that. Okay, example. Okay, 4 kilohertz memory is allocated. So, this is the okay actual main memory allocated to the processor. Is this point clear? Right. Now come to the okay actual first question here. First question क्या है बताओ? Logical address will be greater to physical address. Why? Because the demand of the process. ध्यान से सुनो, पूरा ध्यान से सुनो, इधर ही रखो अच्छे से. Okay, the demand of the process will be always greater. The demand of the process will be always greater. It means what? Process हमेशा ज़्यादा memory मांगेगा. The demand of the process will be always greater. It is not possible to satisfy the demand of the process. It is not possible to satisfy demand of the process. It means what? Process जितना memory मांग रहा है उतना memory आप नहीं दे सकते. We cannot satisfy demand of the process. Why? If you want to satisfy the demand of the process, remember you need to bring all these 8 pages into what? Main memory. You need to bring all these 8 pages into what? Main memory. But remember, practically that is not possible. Practically that is not possible. ओके, प्रोसेस जितना मेमोरी मांग रहा है उतना मेमोरी देना चाहिए. उसको कितना मेमोरी चाहिए हम पे? ओके, 8 किलोवर्ट्स मेमोरी चाहिए. ओके, 8 पेजेस का मेमोरी चाहिए. ओके, वो सारे मेमोरी अपन प्रोसेस को नहीं दे सकते. उसको प्रोसेस जितना मेमोरी मांग रहा है उतना मेमोरी देना चाहिए. तो क्या करना पड़ेगा? यू नीड टू ब्रिंग ऑल दिस 8 पेजेस इनटू व्हाट? मेन मेमोरी. बट रिमेंबर, practically that is not possible. Practically that is not possible. Why it is not possible? Because in our computer main memory is less, but the number of processes are more. In our computer, okay, main memory is less, but the number of processes are more. Is that clear? So, इसलिए you cannot allocate the memory of the demand of the process. वो कितना मेमोरी मांग रहे हैं उतना मेमोरी अपन नहीं दे सकते. Why? Because okay, in our computer main memory is less. In our computer main memory is less, but the number of processes are more. So what we are trying to do, हम लोग करना क्या चाह रहे हैं? अपन करना ये चाह रहा है by allocating less memory to the process. By allocating less memory to the process, we are trying to execute large size process and more number of processes. ध्यान से सुनो, अच्छे से पूरा ध्यान से सुनो. हम करना क्या चाह रहे हैं? By allocating less memory to the process, we are trying to execute a large size process and more number of processes. Indirectly, we are trying to increase the degree of multi-programming. Indirectly, we are trying to increase degree of multi-programming. Obviously, अगर प्रोसेस को कम मेमोरी में ज्यादा प्रोसेस चलाना चाह रहे हैं, ज्यादा प्रोसेस चलाए तो ऑब्वियसली क्या होगा? डिग्री ऑफ मल्टी-प्रोग्रामिंग तो बढ़ेगा ना. If you bring more number of processes to main memory, obviously the degree of multi-programming will increase. So that is the reason. Logical address will be always greater to what? Physical address. So your logical address will be how much here? देखो 13 bits and physical address will be what here? 12 bits. Is that clear for everyone? Right? So I am repeating again the first question only. First question I am repeating once again. The answer is not just say. Why logical address will be greater to physical address? Because the demand of the process will be always greater. Demand of the process will be always greater. It is not possible to satisfy the demand of the process. It is not possible to satisfy demand of the process. Why? If you want to satisfy the demand of the process, you need to bring all these 8 pages into main memory. Whatever the memory it is demanding, you need to allocate that much memory. Okay? You need to bring all these 8 pages into main memory. But practically, that is not possible. Why? Because in our computer, main memory is less, but the number of processes are more. What we are trying to do? By allocating less memory to the process, we are trying to execute a large size process and more number of processes. So indirectly, we are trying to increase the degree of multi-programming, and that is the reason the logical address will be greater to physical address. Is the point clear? Right. So next, now coming to the second point. What the second point? Why CPU always generates logical address? Listen carefully. What the CPU is trying to do? Okay, what is the role of CPU here? CPU's role is what? To execute the process. Simple. To execute the instructions of the process. Now remember, in order to complete the execution of the process, the CPU definitely required to access. In order to complete the execution of the process, the CPU definitely required to access all the pages of LEAS. इसका मतलब क्या है? प्रोसेस क्या CPU करना क्या चाह रहा है? प्रोसेस को चलाना चाह रहा है. प्रोसेस का पेजेस कहां पे है? ये पूरा 8 पेजेस प्रोसेस का पेजेस है. रिमेंबर, प्रोसेस का इंस्ट्रक्शन ये पेज में भी है, ये पेज में भी है, ये पेज में भी, ऑल द पेजेस में पूरा इंस्ट्रक्शन पड़ा हुआ है. इसमें और सारे पेजेस में इंस्ट्रक्शन पड़ा हुआ है. सो प्रोसेस को एग्जीक्यूशन कंप्लीट करना है तो क्या करना पड़ेगा? ये पूरा पेजेस को चलाना पड़ेगा ना, पूरा इंस्ट्रक्शन को एग्जीक्यूट करना पड़ेगा, तभी तो प्रोसेस एग्जीक्यूशन पूरा होगा. In order to complete the execution of the process, the CPU definitely requires to access all the pages of LEAS. इसको चलाना पड़ेगा, इसको चलाना पड़ेगा, इसको चलाना पड़ेगा, सारे पेज को चलाना पड़ेगा. So then only process execution will complete. So that is the reason CPU को तो पूरा पेजेस को तो चलाना ही चलाना है. CPU को तो पूरा पेजेस को एग्जीक्यूट करना ही करना है, क्योंकि सारा पेजेस में इंस्ट्रक्शन पड़ा हुआ है तो ऑब्वियसली एग्जीक्यूट करना ही पड़ेगा. Exactly. So that is the reason when the CPU generates the address, it will generate the address with respect to size of the process. When the CPU generates the address, it will generate the size of the process. Now tell me what the size of the process here? Size of the process how much here? 8 kilowatts. So इसलिए logical address it is generating how much bits? 13 bits. 2 power 13 is 8 kilowatts. Is that clear? I am repeating. फिर से repeat कर रहा हूँ second point. Why CPU generates logical address? In order to complete the execution of the process, CPU definitely requires to access all the pages of LEAS. प्रोसेस का एग्जीक्यूशन पूरा कंप्लीट करना है तो सीपीयू को तो पूरा पेजेस को तो चलाना ही चलाना है, तभी तो प्रोसेस एग्जीक्यूशन कंप्लीट होगा. सो दैट इज द रीजन व्हेन द सीपीयू जनरेटिंग द एड्रेस, इट विल जनरेट द एड्रेस विथ रेस्पेक्ट टू size of the process, with respect to size of the process. Now tell me what the size of the process here? 8 kilohertz. So that is the reason it's generating how many bits of address? Okay, 13 bits of address. Is that clear for everyone? Right. Next, you are having one more important point here. One more important point. Okay, now you will have a doubt. Okay, when I said this second point, you will have one more small doubt. Okay, if anybody is having small doubt. Now what I am saying here, in order to complete execution of the process, CPU definitely requires what? Execute all the pages. ये पेज को भी चलाना है, ये पेज चलाना है, ये पेज चलाना है, सारे पेज तो चलाना है, तभी तो process execution पूरा होगा. But in the main memory, currently you are having how many pages? Currently in the main memory you are having how many pages here? Only 4 pages are there in the main memory. सीपीयू को तो पूरा पेजेस चलाना ही चलाना है, मगर मेन मेमोरी में कितना पेज पड़ा हुआ है? सिर्फ 4 पेज ही पड़ा हुआ है ना, राइट? नाउ रिमेंबर, if the CPU requires to access, CPU requires to execute, okay, let's say page number 4, okay, look at here, so page number 4, what is that? Okay, let's say binary format 100. If the CPU is trying to execute page number 4, that is 100, then what happens? Okay, look at here, page number 4 is not available in the main memory. Look at here, यहाँ पे क्या है? मतलब blank. Okay, so blank means page number 4 is not available in the main memory. Look at here, page number 4 is not there in the PAS. That is not available. Is it clear for everyone? Yes or no? Right? Now look at here. So page number 4 is not available in the main memory. So now what is going to happen now? Okay, CPU is trying to execute the instruction of the page number 4. It is trying to access the instructions available in the page number 4, but page number 4 is not available in the main memory because page table entry के अंदर क्या दिखा रहा है? Blank दिखा रहा है. So blank मतलब क्या है? वो पेज main memory में नहीं है. Now understand here, now what is going to happen? What is going to happen? Now how the process will continue the execution? Okay, that concept we are going to study now. Is that clear for everyone? Yes or no? Yes or no? You have to reply in the mail, okay, saying yes. After this concept is completing, okay, so I want, yes, reply in the, in my mail, okay, right. So understand here. Now the answers अच्छे से, okay, copy करो and note down step by step, okay, step by step अच्छे से proper notes बनाओ. Is that clear? Now first, okay, now let's say step number 1. Note down. Step number 1, the CPU diagram को update करते जाओ और notes में लिखो. Note down. Step number 1. The CPU is trying to access. The CPU is trying to access the page in the main memory. CPU is trying to access the page in the main memory, but the page is currently not available. But the page is currently not available in the main memory. But the page is currently not available in the main memory. Main memory मतलब क्या है बताओ? PAS. Is that clear? If you want to write, you can write PAS. Okay, not available in the PAS. Okay, full stop. Okay, this is called as, braces में लिखना है तो लिखो AB. Okay, this is called as a page fault. Okay, so I am writing here. So this is called as what? A page fault. So this is called as a page fault. Okay, right. So now look at here. So CPU is trying to access that page, but the page is not available in the main memory. So that's called as a page fault. Now tell me whether the page is available or not available. How the CPU will recognize the page is available or not available in the main memory. Okay, actually which bit is maintained to identify whether page is available or not available? Valid invalid bit. If you understand, okay, when I discuss the paging, I told you that valid invalid bit, or you say present bit. So okay, if it is 0, it means that page is not available. Okay, if it is 1, okay, that is available. So that is maintained in the page table entry here. Okay, यहाँ पे एक bit होगा valid invalid bit. Is that clear? Right. So okay, if it is 0, it means that is a page fault. Okay, 0 है तो page नहीं है, 1 है तो page है. Is that clear? That's something like that. Next, now understand here. Okay, I'm repeating the first point. Okay, CPU is trying to access the page in the main memory, but the page is currently not available in the PAS. So this is called as what? A page fault. Now tell me, when the page fault occurs, what is going to happen? When the page fault occurs, immediately what happens? Okay, the process execution will stop. Because CPU को जो पेज चाहिए, वो पेज तो मेन मेमोरी में है नहीं, इजली, तो CPU क्या करेगा? कुछ नहीं करेगा, राइट? सो ओके, द प्रोसेस एग्जीक्यूशन विल स्टॉप, द प्रोग्राम एग्जीक्यूशन विल स्टॉप एंड द सिग्नल विल बी सेंट to the operating system regarding the page fault. Okay, look at here. So step number 2, note down. Okay, update the diagram. Please update the diagram and note down the statement. Okay, so better to use the different color here. If you want, you can use the different color. Update the diagram and note down this point. Update the diagram and note down this point. Note down the pointer. The program execution will stop. Step number 2. Step number 2 बोल के लिखो. Step number 2. Keep it as step number 2. Note down. Step number 2. The program execution will stop. The program execution will stop and the signal will be sent. The program execution will stop and the signal will be sent to the operating system. Regarding the page fault. Program execution will stop and the signal will be sent to operating system regarding the page fault, right? So now understand here. So step number 2, the signal will be sent to operating system, okay, regarding the page fault. Okay, program execution stop हो जाएगा. Okay, signal will be sent to operating system regarding the page fault. And next step, what will happen now? Okay, next step, okay, then okay, once execution is stopped, okay, for that particular program, and the signal will be sent to OS. Next, what happens? Operating system will search for the required page. बताओ सब लोग, आप लोग, okay, operating system will search for the required page in the LEAS. Okay, very good. Note down. Okay, step number 3. Note down. Diagram update करो and notes में लिखो. Step number 3. The operating system. No doubt, the operating system will search for the required page. Operating system will search for the required page in the LEAS. Operating system will search for the required page in the LEAS. Okay, LEAS means what? Okay, braces में लिखो virtual memory. Braces में लिखो virtual memory, right? Now look at here. So we'll search for the required page in the LEAS. So which one is the required page here? Okay, this is the required page. So let's say, okay, page number 4. So required page in the LEAS. Okay. So understand here. Okay, let's try to understand. So this is the okay required page, page number 4. Now next step what will happen now? Okay, no doubt. Next step is okay, step number 4. Okay, step number 4. The required page will be brought from LEAS to PAS. Okay, look at here. Note down. Step number 4. Note down. Step number 4. The required page will be brought from LEAS to PAS. डायग्राम अपडेट करो अच्छे से. डायग्राम अपडेट करके इसको कॉपी कर, नोट पॉइंट को भी लिखो. So the required page will brought from LEAS to PAS. Now tell me, okay, you want to bring this required page from LEAS to PAS, मतलब secondary memory to main memory, or say virtual memory to main memory. So meaning is that. So now understand here, okay, when you are bringing this required page from LEAS to PAS, again you are having one more problem here. Okay, if you want to bring this page number 4 from here to here, you are having one more problem. What is one more problem? There is no free frame available here. कोई खाली फ्रेम नहीं है. कोई खाली फ्रेम नहीं है, सारे ओके फ्रेम्स यहाँ पे फुल है. ओके, सारे फ्रेम्स यहाँ पे फुल है. तो क्या करना पड़ेगा? इन दैट केस व्हाट यू नीड टू डू हियर? यू नीड टू रिप्लेस एनी वन ऑफ द पेज हियर. Replace any one of the page here? Yes or no? Right? So to decide which page you need to replace here, To decide which page you need to replace here, that will be decided by using page replacement algorithms. Page replacement algorithms. याद है थोड़ा थोड़ा? हाँ, बचपन में पढ़े थे, याद है, right? Page replacement algorithms like first in, first out, optimal, LRU, something like that. Okay, right? So understand here. Okay, the answer सुनो अच्छे से. The required page will brought from LS to PS है. Okay, इसको लाना है तो यहाँ पे कोई गाड़ी फ्रेम नहीं है. So कोई भी एक पेज को रिप्लेस तो करना पड़ेगा. So how you decide which page will be replaced? Okay, that will be decided by using what? Page replacement algorithms. Right? Okay, no down. इसमें लिखो step number 4 में और एक point लिखो. Step number 4 में और एक point लिखो. The page replacement algorithms. The page replacement algorithms are used. The page replacement algorithms are used for the decision making of selecting the page for the decision making of selecting the page for the replacement. For the decision making of selecting the page for the replacement. Okay. Right. Okay, understand here. Okay, so I am repeating. Okay. Okay, fine. So for the decision making of selecting the page for the replacement. Okay. Now let us say I decided, okay, some page to be replaced here. Some page to be replaced here. Okay, understand here. So I am replacing some page maybe here. Okay, this one. Okay, just example. So which page you are bringing here? Page number 4. Okay, आप भी replace करो यहाँ पे, change करो. Change करो. चेंज करो. राइट. सो अंडरस्टैंड हियर. ओके, सो यहाँ पे पेज नंबर 5 को मैं रिप्लेस किया पेज नंबर 4 से. ओके, द आंसर सुनो अच्छे से. पेज नंबर 5 को रिप्लेस किया पेज नंबर 4 से. राइट. सो यहाँ पे जो पेज चाहिए अपने को, अपन वो पेज में मेन मेमोरी लाया. नेक्स्ट स्टेप क्या होना चाहिए? ओके, सोच के बताओ अच्छे से, सोच के बताओ. नेक्स्ट स्टेप क्या होना चाहिए? जो पेज मेमोरी चाहिए अपने को वो मेमोरी में लाया. So once you bring the required page into main memory, so now tell me what should be the next step? What should be the next step? Think and tell me what should be the next step? क्या होना चाहिए? सोचो अच्छे से. जो पेज मेन्यूअर लाया वो तो आया. ओके, जो पेज चाहिए अपने को मेन मेन्यू वो तो लाया. उसके बाद क्या होना चाहिए? नेक्स्ट स्टेप इज वेरी वेरी इंपॉर्टेंट. यू नीड टू अपडेट द पेज टेबल एंट्री. You need to update the page table entry, because if you don't update the page table entry here, then still it will show you what here? Blank only. And still will show you blank only. If it's still showing blank, again the page fault will occur. Yes or no? Right? No doubt. Step number 5. Okay, step number 5. Okay, no down. Okay, sorry, remove this. Okay, step number 5. The respective page table entry. No down. The respective page table entry will be updated. Respective page table entry will be updated accordingly. The respective page table entry will be updated accordingly. Okay, understand here. The respective page table entry will be updated accordingly. इसका मतलब क्या है? Okay, the answer सुनाई दे रहा. Okay, respective page table entry will be updated accordingly. Okay, what is that here? Okay, page number 5. First, page number 5 was initially available in the frame number 1. Page number 5 is initially available in the frame number 1, but now that is no more available. So this will be made as what? Blank. And page number 4, it was not available, but now it is available in the frame number 1. And you need to update this with what? Okay, frame number 1, that is 0, 1. Okay, so please update this. Change करो अच्छे से. पेज नंबर 5 इससे पहले था, अभी नहीं है, तो ब्लैंक करो. पेज नंबर 4 इससे पहले नहीं था, अभी है, तो इसको कौन सा फ्रेम में है अभी? वो फ्रेम नंबर 1. सो फ्रेम नंबर 1 01. सो अपडेट विद द फ्रेम नंबर, दैट इज 01. राइट. नेक्स्ट नाउ नेक्स्ट स्टेप व्हाट हैपेंस? लिसन केयरफुली. नाउ सो वंस यू ब्रिंग द रिक्वायर्ड पेज एंड अपडेट द पेज टेबल एंट्री, नेक्स्ट स्टेप नंबर 6. ओके, लिसन केयरफुली. स्टेप नंबर 6. ओके, लिसन हियर. The signal will be sent. पहले सुनो. the signal will be sent to the CPU. Okay, signal will be sent to the CPU to continue program execution, and CPU will access the required page in the main memory and continue the program execution. Continue the program execution. Is that clear? Right. Note down. Step number 6. Note down. Step number 6. The signal will be sent. The signal will be sent to the CPU. The signal will be sent to the CPU to continue program execution. Signal will be sent to the CPU to continue the program execution, and the CPU will access the required page. The CPU will access the required page in the main memory. CPU will access the required page in the main memory and continue program execution. Continue program execution. Okay. So fine. Okay, understand here. So CPU will access the okay, understand here. Repeating last point. Signal will be sent to the CPU to continue program execution, and CPU will access the required page in the main memory and continue program execution. So remember, so this is what is actually happening in our computer. Okay, this is what is actually happening in our computer. Okay, so I repeat all the points. Okay, ध्यान से सुनो, पूरा ध्यान इधर रखो, पूरा ध्यान इधर रखो. Okay, listen carefully. Okay, now remember. Okay, first, when the CPU is trying to access page number 1, okay, page number 4, it is not available, so the page fault will occur. So when the page fault occurs, immediately what happens? The program execution will stop and signal will be sent to operating system regarding the page fault. Then OS will search for the required page in the virtual memory. Okay, so it will search for the required page in the virtual memory, and next the required page will be brought from LEAS to PAS. Required page will be brought from LEAS to PAS, and again the page table entry will be updated. Okay, page table entry will be updated accordingly. Okay, यहाँ पे update हो जाएगा, and then the signal will be sent to the CPU to continue the program execution. Is that clear? So this is how by allocating the less memory to the processor, we are trying to execute a large size process. Look at here. If you observe the process size, what is the size of the process here? 8 kilowatts. And what is the main memory allocated to the process here? 4 kilowatts. Look at here. You are executing the 8 kilowatts of the process on the main memory of 4 kilowatts. You are executing 8 kilowatts of the process on the main memory of 4 kilowatts. So how that is actually happening? That's actually happening with the help of demand paging or with the help of virtual memory. With the help of demand paging, or say with the help of virtual memory. Is that clear for everyone? Right? Now I am coming from the first, okay, from the beginning. Listen carefully. I am coming from the beginning. Okay, the answer is not to say. Whenever the process is created, what is the meaning of creating the process? Okay, double click on the game. कोई game चला रहा है, कोई गाना चला रहा है, कोई application चला रहा है, okay, कोई movie चला रहा है. So everything is a process. Everything is a process. Whenever the process is created, paging will be applied on the process. Page size will be already predefined in the computer. Windows practically follows page size of Bolo 4 KB. Very good. Now understand here. So paging will be applied on the process. It will be divided into pages. Paging will be applied on the process, and page table will be created. Paging will be applied on the process. Page table will be created. Respective page table entries will be updated. And base address of the page table will be updated, right? And initially all the pages will be in the virtual memory. Initially all the pages will be in the virtual memory, and some of the pages will be brought into main memory. Some of the pages will be brought into main memory, and okay, accordingly page table entries will be updated, and base address of the page table will be stored in the PCB, process control block. Is that clear for everyone? Right? मैं repeat कर रहा हूँ फिर से ध्यान से सुनो. Okay, repeat कर रहा हूँ. Whenever the process is created, paging will be applied on the process. Initially, all the pages will be in the virtual memory. Initially all the pages will be in the virtual memory and some of the pages will be brought into main memory. Some of the pages will be brought into main memory and the pages which are present in the main memory. Okay, next the page table will be created and this respective page table entries will be updated. मतलब जो pages main memory में देखो page number 7 का ये entry update होगा, page number 5 लाया वो का available है. Okay, जो pages available है उसका entries update होगा and the base address of the page table will be stored in the PCB. And when the CPU is executing the process, whatever the pages available in the main memory, okay, what are the pages available in the main memory, the CPU will execute those pages. The pages which are present in the main memory, CPU will execute those pages. And if the CPU requires any additional page which is not there in the main memory, if the CPU requires any additional page which is not there in the main memory, then what happens? The page fault will occur. And when the page fault occurs, the program execution will stop for some period of time. And the signal will be sent to operating system regarding the page fault, and OS will search for the required page in the LES and the required page will be brought from LES to PAS, and again the page table entry will be updated and again the CPU signal will be sent to CPU to continue program execution. Is that clear? So this is what is actually happening in our computer. It is practically happening in our Windows operating system. Is that clear for everyone? Right? So if it is yes, sir, you have to reply me with yes, sir. Okay, right? I am repeating once again. मैं पूरा repeat कर रहा हूँ, the answers सुनो अच्छे से, पूरा ध्यान इधर रखो. Is that clear? Okay, right. I am repeating once again all the points. Whenever the process is created, last time repeat कर रहा हूँ. Whenever the process is created, paging will be applied on the process. Initially, all the pages will be in the virtual memory, and some of the pages will be brought into main memory. And page table will be created and respective page table entries will be updated and base address of the page table will be stored in the PCB. And the pages which are present in the main memory, CPU will execute those pages. And if the CPU requires any additional page which is not there in the main memory, then what happens? The page fault will occur. When the page fault occurs, the program execution will stop for some period of time. The signal will be sent to OS and you know the remaining story. Is that clear? Signal will be sent to OS and OS will search for required page in the virtual memory and the required page will be brought from LES to PS and again the page table entry will be updated and again the signal will be sent to CPU to continue program execution. So this is what is actually happening in our Windows operating system. Is that clear? Okay. Remember, if you go to any interview or anything, if somebody says what is virtual memory, non-stop 15 minutes you have to explain all this. Okay, what is the process create होते क्या होगा, इसके ऊपर paging कैसे होगा, you write this complete diagram, okay, with all the definitions, with all the points, whatever I said exactly you have to say. If somebody asks you what is virtual memory in interview, non-stop you have to talk for 15 minutes. Okay, non-stop you have to discuss only 15 minutes. Okay, वो खुद बोलना चाहिए. Okay, तुमको मालूम है. Okay, अभी रुक जाओ. समझ में आया सबको? Right, and understand here. Next, understand carefully. Okay, small point. ये सारे okay steps है 1 2 3 4 5 6. Okay, थोड़ा सोच के बताओ. Okay, which step will take more amount of time among all this? Which step will take more amount of time? 1 2 3 4 5. इसमें okay कौन सा step के लिए ज्यादा टाइम लगेगा? Step number 4 के लिए ज्यादा टाइम लगेगा, because you are bringing the page from your secondary memory to main memory. You are bringing the page from secondary memory to main memory, right? So this will take more amount of time. That is the important point. Next, now understand carefully. The next is very important point. Listen carefully. I said in all our modern operating systems we are using virtual memory. In all our computers virtual memory पक्का होगा ही होगा, right? Definitely है. Okay, right? So why this virtual memory concept is used? Okay, why this is used? I already told you why virtual memory concept is used. Okay, the main purpose of virtual memory is, ध्यान से सुनो अच्छे से, पूरा ध्यान इधर रखो. The main purpose of virtual memory is by allocating less memory to the process and we are trying to execute a large size process and more number of processes. Indirectly, we are trying to increase the degree of multi-programming. Indirectly, we are trying to increase degree of multi-programming. Is that clear? Now remember, what happens if you remove the virtual memory from your computer? Let's discuss this point also. अगर मैं वर्चुअल मेमोरी को हटा दिया, सिस्टम में वर्चुअल मेमोरी हटा दिया, हटा देना मतलब क्या है? अभी देखिए वर्चुअल मेमोरी कहां पे, लैपटॉप में देख चुका है सब लोग, कहां पे? अगर वो वर्चुअल मेमोरी को आप क्या करो, जीरो कर दिया तो क्या होगा? अगर वर्चुअल मेमोरी को जीरो कर दिया तो क्या होगा बताओ? अगर वर्चुअल मेमोरी को आप जीरो करके आप कर सकते हो, लैपटॉप में कर सकते हैं, कैसे करना मैं बताऊंगा अभी, ओके, टेंशन मत लो, राइट? अभी वो जीरो करके अगर आपने सेट किया तो क्या होगा? अगर वर्चुअल मेमोरी को पूरा जीरो कर दिया तो क्या करना पड़ेगा? ये पूरा प्रोसेस जो है वो पूरा मेन मेमोरी में लाना पड़ेगा। यस और नो? अगर वर्चुअल मेमोरी हटा दिया, जीरो कर दिया तो पूरा प्रोसेस को मेन मेमोरी लाना पड़ेगा। सो इफ यू ब्रिंग द एंटायर प्रोसेस इनटू मेन मेमोरी, यू विल हैव ओनली लेस नंबर ऑफ प्रोसेसेस इन द मेन मेमोरी. When you have less number of processes in the main memory, degree of multi-programming will decrease and your system performance will become very slow. आपका कंप्यूटर वेरी धीरे धीरे चलेगा, बहुत स्लो चलेगा। आप क्या करो, एक काम करो, लास्ट में, ओके अभी नहीं, ओके पूरा लेक्चर सुनने के बाद लास्ट में आप ये ट्रायल करो। क्या करो? वर्चुअल मेमोरी को जीरो करो। कैसे करना ऑलरेडी बताया। वर्चुअल मेमोरी कहां पे अपडेट होता है, कहां पे सेट करके रहता है, ओके माय कंप्यूटर, गो टू प्रॉपर्टीज, एडवांस प्रॉपर्टीज, वर्चुअल मेमोरी। सो जस्ट गो टू दैट ओके प्लेस। वो वर्चुअल मेमोरी जो है फर्स्ट राइट दैट ओल्ड वैल्यू ओके इन द पेपर। जो पुराना वैल्यू है उसको अच्छे से नोट्स में लिख के रखो। ओके मेरे हिसाब से 5000 MB ऐसा कुछ रहेगा। 5000 MB मतलब ओके 4 GB समथिंग लाइक दैट और 5 GB समथिंग लाइक दैट। ओके सो 4000 to 5000 MB ऐसा कुछ रहेगा। जो पुराना वैल्यू है उसको अच्छे से लिख के रखो। पुराना वैल्यू जो है उसको अच्छे से लिख के रखो। उसके बाद क्या करो, वहां पे जीरो करो। जीरो करके नीचे बटन रहता है सेट करो और नेक्स्ट अप्लाई चेंज जो भी है सेव करने के बाद रीस्टार्ट करो कंप्यूटर। देखो क्या होता है, आप अपने आंखों से देख सकते हैं क्या हो रहा है। वर्चुअल मेमोरी हटा दी तो क्या होगा, पूरा प्रोसेस को मेन मेमोरी लाना पड़ेगा। तो बिल्कुल 2-3 प्रोसेस या 10 प्रोसेस मेन मेमोरी में रहेगा। ओके इसका मतलब बहुत स्लो चलेगा, धीरे 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 चलेगा। अगर आजकल नया कंप्यूटर में क्या हो गया, वर्चुअल मेमोरी को जीरो करने को नहीं देगा वो। If it is not allowing to make the virtual memory as zero, then what you will do? Okay, simply make it as a 1000 MB there. 1000 MB करो, नहीं तो 500 MB करो, बहुत कम कर दो। Okay, if it is having around 5000 MB there, okay, simply make it as a 500 MB or 100 MB, something like that, and simply make it a set करके, save change करके सिस्टम रिस्टार्ट करो। देखो क्या होगा, बहुत स्लो हो जाएगा सिस्टम। समझ में आ रहा है? डरने की कोई जरूरत नहीं है, आपका लैपटॉप को कुछ नहीं होगा, राइट? टेंशन लेने की जरूरत नहीं है। समझ में आया, राइट? सो आप प्रैक्टिकली देख सकते हैं वर्चुअल मेमोरी का इंपॉर्टेंस क्या है। इज दैट क्लियर फॉर एवरीवन? राइट, ओके। सो जस्ट नोट डाउन वन इंपॉर्टेंट पॉइंट, कीप इट एज नोट, सो प्लीज नोट डाउन दिस पॉइंट। Please keep it as this note. Keep it as note. Note down this point. The main purpose of virtual memory is by allocating less memory to the process we are trying to execute large size process and more number of processes indirectly we are trying to increase degree of multi-programming. Indirectly we are trying to increase degree of multi-programming. Okay, full stop. If the virtual memory is next continuation only. If the virtual memory is removed from the system, then efficient implementation of multi-programming and multi-user no longer possible. Is that clear? Right. Okay, fine. So if the virtual memory is removed, then what happens? Obviously, efficient implementation of multi-programming possible नहीं होगा, multi-user भी possible नहीं होगा. Multi-programming ही possible नहीं है, तो multi-user भी obviously possible नहीं होगा. Is that clear? क्योंकि उसके लिए क्या चाहिए? बहुत ज़्यादा memory चाहिए, something like that. Okay. So that is the important thing, right? So that point you should remember. Okay. And next, okay, continuation. Just note down. Next, page fault service time. Note down. Keep the heading. Page fault service time. Note down this point. Keep the heading. Page fault service time. Note down. The time taken to service a page fault. Time taken to service the page fault is called as page fault service time. Time taken to service a page fault is called as a page fault service time. Full stop. The page fault service time includes the time to perform all the above 6 steps. Time to perform all the above 6 steps. Okay, right? Above 6 steps मतलब ये वाला 1 2 3 4 6 steps है ना, ये टाइम के लिए जितना टाइम लगेगा, that is called as a page fault service time. Time to above 6 steps. Okay, ये सारा 6 steps. Okay, right? Okay, understand here. So simple definition है page fault service time. What is that here? Time taken to service a page fault is called as a page fault service time. So जब भी page fault आता है, whenever the page fault occurs, how much time you are taking to service this? Okay, that time is called as what? Page fault service time. And page fault service time includes time to perform all the 6 steps. ये सारे 6 steps के लिए जो time है, so that time is called as a page fault service time. Okay, no doubt. Next, continuation में लिखो next. Page fault service time equal to yes. No doubt. Page fault service time equal to yes. Next line. Main memory access time. Main memory access time equal to M. Main memory access time equal to M. And next line में लिखो page fault rate. Page fault rate equal to P. Page fault rate equal to P. यहाँ पे लिखा है. The answer अच्छे से रिपीट कर रहा हूँ. Page fault service time yes. Main memory access time M. Page fault rate, okay, that is a P. Is that clear? So page fault rate means what? Let's say, okay, is referring around 10 pages. Let's say is refer 10 pages, and out of which around 3 were the page fault. 10 pages को refer किया, उसमें से 3 page faults आया, तो page fault rate क्या होगा? 3/10. Very good, 3/10. Okay, that's a page fault rate. Okay, right. So, okay, that's a page fault rate P. Okay, no doubt. Next line में लिखो. Then, next line में लिखो. Then the formula for effective memory access time. Then the formula for effective memory access time. Okay, right. So understand here, then the formula for effective memory access time. Okay, now just listen here. Formula for effective memory access time. Page fault rate is a P here. Just listen here. Page fault rate is P. Okay, listen here. Page fault rate is a P here, and main memory access time M, and page fault service time is S. So please listen carefully. Formula for effective memory access time with respect to page fault rate P. So now P is a page fault rate. Okay, whenever the page fault occurs. Listen here. Whenever the page fault occurs, you apply what? Service time. Remember, service time means that includes everything. Everything is included in the service time. So whenever the page fault occurs, you apply service time plus. And remember, P is a page fault rate, then no page fault will be what? 1 minus P. And when there is no page fault, listen here. Okay, there is no page fault means what? 1 minus P. So when there is no page fault, okay, we'll have what? Main memory access time M. Okay, so P into S plus 1 minus P into M. So this is the formula for effective memory access time with respect to page fault rate P here. Now remember, you will have a small doubt in this. Don't worry, all your doubts I will clarify. So first, listen carefully. Effective memory access time with respect to page fault rate P. So whenever the page fault occurs, listen carefully. Whenever the page fault occurs, you apply service time. Remember, service time includes everything. So there is no doubt here. आपको यहाँ पे doubt नहीं होना चाहिए. There is no doubt here. Okay, everything is very clear here. When the page fault occurs, you apply the service time. Remember, when there is no page fault, obviously no P is a page fault means no page fault is 1 minus P. When there is no page fault, okay, you apply what? Main memory access time. Remember, when there is no page fault, what is actually happening here? When there is no page fault, you access the page table here. Just listen here. Whenever the page fault, there is no page fault, you access the page table and you access the actual page here. When there is no page fault, you access the page table and the actual page. Okay, it means you have to write M here and 1M here. That is M plus M. That is what? 2M. Okay, just listen here. So 1M here and 1M here. M plus M, 2M लिखना चाहिए. 2M आपको लिखना चाहिए, but you write only 1M. Why? Because the page table access time will be neglected. The page table access time will be what? Neglected. Understand here. So you simply ignore the page table access time. Okay. So why? Because, and one more reason also there, the service time will be very, very greater compared to main memory access time. Just listen first. पहले सुनो मैं जो बोल रहा हूँ. Service time will be okay, very, very greater compared to main memory access time. So service time will be in the actually in the milliseconds, and main memory access time will be actually in the nanoseconds. Okay, service time will be actually in the milliseconds, and okay, main memory access time will be in the nanoseconds. So that is the reason we simply ignore the page table access time. मैं रिपीट कर रहा हूं फिर से, किसी को डाउट होता है यहाँ पे, इसलिए मैं रिपीट कर रहा हूं. When the page fault occurs, you apply service time. Remember, service time में सब कुछ इंक्लूडेड है. यहाँ पे भी किसी को अगर डाउट है, ओके, आप अच्छे से स्टेप नंबर 6 में जो लिखा है उसको पढ़ो अच्छे से. स्टेप नंबर 6 में लिखवाया, ओके, और पूरा दोबारा इसको एक्सेस करने का जो टाइम है उसको भी इंक्लूडेड है. सब कुछ यहाँ पे इंक्लूड है. यहाँ पे तो डाउट नहीं होना चाहिए. जब whenever the page fault occurs, you apply service time. But remember, when there is no page fault, okay, when there is no page fault, you are actually accessing page table and also the actual page. So M here and M here. So that is M plus M, 2M. 2M लिखना चाहिए, but you write only 1M. Why? Because page table access time will be neglected. Okay, इसमें कोई दूसरा रीजन कुछ भी नहीं है. Okay, ज्यादा टेंशन लेने की जरूरत नहीं है. हम लोग ऑलरेडी रिसर्च कर चुके हैं. Is that clear? Right. So that is only 1M. Remember, you need to follow the same formula to solve all the gate questions. Right. So, and one more important reason also what? Service time will be very, very greater compared to main memory access time. Remember, service time will be actually in the milliseconds, and okay, main memory access time will be in the form of nanoseconds. Is that clear? So, okay, that is also one more reason. You can simply ignore that. Okay, right. So, don't think all that. Okay, simply follow the formula. Is that clear? So, I am repeating, effective memory access time equal to P into S plus 1 minus M into 1 minus P into M. Is that clear? So, next we are going to solve the various questions. Okay, from low level to high level. Okay, we are going to discuss various questions. Okay, so based on the page fault service time and also with respect to effective memory access time. Is that clear? So, I will slowly increase the complexity low level to high level. Is that clear? So, next we are going to discuss the questions. Okay, so just revise the all the points carefully, and next we will take up the questions. Okay, so I think all of you following, right? Thank you. So dear students, next we'll take up the questions. So finding out effective memory access time with respect to page fault rate P. Now, okay, I'll slowly increase the complexity. So low level to high level. So sincerely, everyone try to solve the problems. Okay, right. So note down the first question. Okay, note down. Consider a system which has the main memory access time of 35 nanoseconds. I have written here main memory access time of 35 nanoseconds and page fault service time is 175 nanoseconds. वैल्यूज मैं बोर्ड के ऊपर लिखता हूं. ओके, डाउट है तो देख सकते. पेज फॉल्ट सर्विस टाइम इज 175 नैनोसेकंड्स and page hit ratio is 75%. Page hit ratio is 75%. Then what is the effective memory access time? What is the effective memory access time? So please try to solve the problem. Okay, formula is given to you. Okay, already you are having formula. So try to substitute all the values in the formula and so that you can easily solve. Understand the each and every word given in the question. So try to think carefully and solve the problem. So solve that. I will wait 5 seconds in the live. Then I will explain. Pause कर लो आप, video pause करो. Please pause my video and try to solve that. Okay, so I am assuming all of you solved. So let's try to understand here. So many people are doing mistake. Okay, I understand. Okay, they are getting something 200 something. I don't know what is the answer you are getting. So right answer is 70 nanoseconds. 70 nanoseconds. So please don't try to substitute the values blindly in the formula. Understand the everything what is given to you. Now understand here what I said here. Okay, page hit ratio is a 75%. That's what I said. Page hit ratio is a 75%. Now tell me, in the effective memory access time formula, okay, you are having P into S plus 1 minus P into M here. So what is the meaning of P here? What is the meaning of P? क्या लिखा है यहाँ पे? देखो, page fault rate. I have written, what I have written there? Page fault rate is given to you. But remember, in the question what I said, okay, page hit ratio is given to you. What is P here? यहाँ पे P मतलब क्या था? Page fault rate. इतना अच्छा लिखा है, बोर्ड के ऊपर देखो यहाँ पे इतना अच्छा लिखा है page fault rate. But what is given here? Page hit ratio is given. So it means what is given to you? P is given or 1 minus P is given? Okay, 1 minus P is given. Okay, so please understand. So page hit ratio is the 1 minus P. Look at here, this is a page fault rate. P is a page fault rate. So page hit ratio क्या होगा? No page fault, or you say page hit ratio. It means what? 1 minus P. So 1 minus P is given as 75%. So page hit ratio 75% है. तो page fault rate क्या होगा? 25%. So that is a 0.25 multiply with the service time. What is service time given to you? 175 nanoseconds. So all are in the nanoseconds. There is no problem. Place. Okay. And next, now tell me. Next is what? Okay. So page hit ratio कितना दिया बताओ? 0.75. And if the page hit ratio है तो okay, then you apply main memory access time. So what is the main memory access time given to you? 35 nanoseconds. So just try to solve this equation and you will get the answer. So okay, so right answer is 70 nanoseconds. 70 nanoseconds. So please try to solve that. Don't make any calculation mistakes. Okay, right. So thank you. Next. So let's move on to the workbook. Let's solve some other questions from the workbook. So go to your workbook, page number 111. So please discuss this. Okay, so I'm writing the page number here. So page number 111. Question number is 20. Okay, so I'm removing this. Okay, question number 20. Solve this. Question number 20. So read the question carefully and try to solve. Page number 111, question number 20. So that's in the virtual memory. So please try to solve that. I'll wait 5 seconds in the live. So otherwise I'll explain. Same formula. You have to use the same formula. थोड़ा सोचना है. Exactly the same formula you have to use. There is nothing different. But you need to think a little bit. थोड़ा सोचने का है, बस उतना ही. Page number 111, question number 20. Right. So I am moving on to the explanation. So if anybody is still not solved, you can pause my video. Okay. Right. So what is said in the question, understand here. Okay. So I am just reading the question here. An instruction takes I microseconds. Please listen to this carefully. An instruction takes I microseconds and an additional j microseconds if the page fault occurs. Listen carefully. An instruction takes I microseconds and an additional j microsecond if the page fault occurs. Look at here. Instruction takes I microseconds and additional j microsecond if the page fault occurs. So if that is the case, now tell me main memory access time कितना दिया? Main memory access time I हो गया. Okay, instruction takes I microseconds and additional j microsecond if the page fault occurs. So service time will be what? What will the service time here? That is I plus j. I plus j will be the service time. I plus j will be the service time. Is that clear? Next क्या दिया बताओ? And okay, page fault occurs. I am repeating. Page fault occurs on an average for every k instructions. What is the effective instruction access time? If the page fault occurs on an average for every k instructions. Page fault occurs on average for every k instructions. Understand this point here. हर k instruction को page fault आता है. Like for example, हर 10 instruction को page fault आ रहा है. Example I am saying. हर 10 instruction को page fault आता है. हर 10 instruction को page fault आता है. तो इसका मतलब page fault rate क्या हो जाएगा? 1/10 हो गया. Same thing in the question it says for every k instructions the page fault occur. हर k इंस्ट्रक्शन को पेज फॉल्ट आ रहा है. हर k इंस्ट्रक्शन में एक पेज फॉल्ट आ रहा है. इसका मतलब ये है. तो इट मींस पेज फॉल्ट रेट क्या हो गया? 1/k हो गया. 1/k. Okay, look at here. So I am writing here. So page fault rate will be what? 1/k. So these are the values you are having. So you need to solve the formula. Okay, just substitute in the formula here. So page fault rate is a p. What is that here? 1/k. Multiply with the s value is how much here? I plus j. S is I plus j plus 1 minus 1/k multiply with the I. Okay. So please try to derive this equation here. So what is this here? Okay. I by k plus j by k plus I minus I by k. So minus I by k plus I by k cancel here. So what will the answer here? Tell me. I plus j by k. So this is how you need to solve the problem. Okay. I plus j by k. So the right answer is what? Okay. B. B is the right answer. So this is how, okay, you need to solve the problem. So check कर लो आप लोग कैसे सोचे थे और मैं कैसे बताया, right? So please try to solve the problem, okay, in that manner. And next, let's solve the next question. Okay, I am following the proper sequence of questions. So follow in the same manner. So page number 113, question number 37. Page number 113. So I am writing here properly. Page number 113, question number is 37. Question number 37. Okay. Question number 37. Okay, in that I am giving options. So please note down the options also. Okay, I am giving the options. I am writing options here. Okay, just listen here. I am giving the options. Okay, options are 25 nanoseconds, 30 nanoseconds, 35 nanoseconds, option D 40 nanoseconds. So options are given to you. So think carefully and answer. Page number 37, page number 113, question number 37. So I have written the that page number 113. Okay, question number 37. Options are given to you. So think carefully and solve. Same formula you have to use. Same formula you have to use. So please pause my video. I'll wait 5 seconds in the live. Please pause my video and try to solve. Right. Okay. So I'm discussing that. Let's see what okay, page fault rate. Okay, this is just like similar kind of question, previous question only. Page fault rate is given as what? One page fault occurs for every 10 power 6 memory references. One page fault occurs for every 10 power 6 memory references. So page fault rate will be what? Tell me. 1 by 10 power 6. So multiply with service time is given as what? 10 milliseconds. So plus 1 minus 1 by, okay, 1 minus 1 by 10 power 6. Okay, multiply with the main memory access time is given as what? 20 nanoseconds. So that's all. So these are the values given to you, right? So understand here, just okay, just solve this equation, right? Just solve the equation and you get the right answer as what? Okay, B is the right answer, 30 nanoseconds. Okay, so कुछ लोग सोच रहे हैं सर यही तो नहीं आ रहा इसलिए नहीं कर पाया, right? Why you are worried? Okay, you are finding difficult to convert milliseconds, nanosecond convert करने में मुश्किल हो रहा है. Okay, understand here. So please understand. So 1 millisecond equal to how many nanoseconds? बोलो वहां से. Okay, 1 millisecond equal how many nanoseconds? कुछ लोग बोल रहे हैं 10 power minus 6 minus 9 okay minus 3 पता नहीं क्या बोल रहा है minus बोलो. Okay, जो चाहे वो बोलो, enjoy करो. So that is equal to 10 power 6 nanoseconds. Is that clear? So this is the right answer. 1 millisecond equal to 10 power 6 nanoseconds. So you can just substitute here. So look at here, 1 by 10 power 6 multiply with the 10 multiply with 1 means 1 millisecond equal to 10 power 6 nanoseconds. So 1 millisecond I am converting everything into nanoseconds because final answer is given asking in the nanoseconds. So this 10 power 6 nanoseconds ho gaya. This is 1 minus 1 by 10 power 6 multiply with the 20 nanoseconds, correct? So this 10 power 6 cancel. And what is this value here? 10 nanoseconds here. Okay, 10 nanoseconds plus. So understand here 1 minus 1 by 10 power 6. Okay, 1 minus 1 by 10 power 6. 1 में से 1 by 10 power 6 को okay subtract करना है. So this value is what? Okay, almost equal to 1 only. Right? So if you want exact value of this, multiply with 20 nanoseconds is there. Okay, if you want exact answer that will be 19.9999 nanoseconds like this. So total combined together, so that becomes 29.9999 nanoseconds and that is equal to what? Approximately equal to 30 nanoseconds only. Is that clear? So exact answer if you want 29.9999 nanoseconds ऐसा कुछ होगा. So in the question also is asking approximate, that is given to you in the question. So right answer is what? 30 nanoseconds. So this is how okay you need to solve the problem. Right. So let's move on to the okay next question in the workbook. So go to page number 110. Okay, so I am writing that 110 question number 13 13. Page number 110 question number 13 13. So please solve this question. Question number 13. Okay, just listen here. So I am giving the small hint. Okay, small hint for this question. Okay, just listen this hint and after that okay you can solve the problem. 1 minute सुनो इधर पहले. I am explaining some important point and later you can solve that. Pause करके. Okay. Now just listen here to solve this question. Whenever the page fault occurs, understand this point here. Okay, I am just revealing. Okay, just listen here. Listen to me this point. Afterwards, you can solve this. So, whenever the page fault occurs, we are loading the page. Okay, from your LES to what? PS. You are bringing the page from virtual memory to secondary memory. Now, remember when you are bringing the page from virtual memory to main memory here, you are having two cases. One is the modified page and next is a not modified page. Listen carefully. One is a modified page and next is a not modified page. Let us say for example, okay, look at here, you are bringing the page. जब भी page fault आता है, you bringing page from virtual memory to okay main memory, or say secondary memory to main memory. Now when you are bringing the page like this, if this old page, listen carefully. What's the old page here? Okay, page number 5 here. If the page number 5 is not modified page, If the page number 5 is not modified, then what happens? You simply bring this page, okay, page number 4 को यहाँ से लाओगे and simply directly, okay, replace here. I am repeating, old page, पुराना page यहाँ पे जो था, okay, page number 5, if that is not modified page, okay, simply load that and okay, bring that page number 4 को लाएंगे and simply replace here, okay, that is a not modified page. In case, if the page number 5 is a modified page, so how do you know it is modified? How do you know it is modified? With the help of, okay, modified bit, or you say dirty bit. I think all of you remembered, we discussed clearly in the paging. So, dirty bit is used, dirty bit or modified bit is used to identify whether the page is modified or not modified. So, in case, if this page number 5 is modified page, listen to me carefully, if the page number 5 is a modified page, if it is modified page, you cannot simply, okay, replace like this because you have a different page here and you have a different page here. Because while execution, when the CPU performing execution, maybe it is updated some instruction here. If the page number 5 is modified, in that case, what you have to do? You have to bring this, okay, page number 5 from PAS to LAS. And you need to replace this page, okay, page number 4 from your LAS to PAS. So, in case if that is a modified page, you are having two steps. If it is a modified page, you are having two-step process. Okay, पहले पुराना पेज को यहाँ से इधर लाना पड़ेगा और नया पेज जो है, okay, इसको इधर से इधर लाना पड़ेगा. So, in that case, you are having two-step process. Okay, remember, now tell me, okay, now tell me, you are having two cases, modified case and not modified case. In which case it will take more time? सर्विस टाइम कब ज्यादा होगा? मॉडिफाइड है तो ज्यादा होगा, नॉट मॉडिफाइड है तो ज्यादा होगा, मॉडिफाइड है तो ज्यादा होगा. वेरी गुड. इफ इट इज मॉडिफाइड, ओके, यू आर एक्सेसिंग द, ओके, सेकेंडरी मेमोरी टू टाइम्स. इफ इट इज मॉडिफाइड, यू आर एक्सेसिंग द सेकेंडरी मेमोरी टू टाइम्स. अगर मॉडिफाइड पेज है तो ओके, ज्यादा टाइम लगेगा. इज इट क्लियर? सो व्हाई वी हैव नॉट डिस्कस्ड दीस पॉइंट्स व्हेन यू आर डिस्कसिंग ऑल द 6 स्टेप्स हियर? व्हाई वी हैव नॉट डिस्कस्ड? बिकॉज दैट इज द स्पेशल केस. That is a special case and that is the reason we did not discuss all that. Is that clear for everyone? Right. So, now come back to this question here. In that question, okay, page number 110, question number 13. In the question also you are having same thing here. Look at here, whenever the page fault occurs, just listen 2 minutes here, later you can solve the problem. Okay, whenever the page fault occurs, you are having two cases. One is a modified case and next is a not modified page. Okay, you are having two cases, modified page and not modified page. So, how much percentage it is modified? Okay, read that question he has given. So, 70% is given as modified page. So, in that obviously not modified will be how much here? 30%. And if it is a modified page, how much service time is taking? 20 nanoseconds. And if it is not modified page, how much service time is taking? 8 nanoseconds. Okay, 8 nanoseconds or milliseconds. Okay, just check it out. Okay, so yeah, sorry, it's a milliseconds. Okay, right? So, okay, this is a, okay, modified page, it is a 20 milliseconds. Not modified page is taking 8 milliseconds. Okay, so same formula you have to use, EMAT equal to P into S plus 1 minus P into M. In this case, you are having two things. Whenever the page fault occurs, the answer is not just say, whenever the page fault occurs, you are having two cases. One is a modified case and next is a not modified case. If it is modified case, okay, you are taking different service time. If it is a not modified case, you are taking the different service time. Is that clear? So, the formula will be same. Okay, so just think only in this area. Try to solve the problem. So, I will wait 5 seconds in the live. Okay, so please pause my video and try to solve. I will wait only 5 seconds. Pause kar lo aap. If you want to solve, so please pause the video and try to solve. Okay, so I am assuming all of you solved. If anybody not solved, you can still pause my video. Now, so I am just okay solving this. Now tell me, okay, page fault. Okay, whenever the page fault occurs, you are having two cases. Now, what is that case? Whenever the page fault occurs, so page fault rate you need to find out. Okay, is asking page fault rate, maximum acceptable page fault rate to reach the effective memory access time not more than 2 milliseconds. Is that is the case, right? Okay, so page fault rate you need to find out. So P value you need to find out. Whenever the page fault occurs, you are having two cases, modified case. So 0.70. Okay, look at here. Okay, 0.70 modified case. If it is a modified case, you are taking how many milliseconds? 20 milliseconds. Okay, now tell me 30% modified hai, so not modified is how much here? Okay, sorry, 70% modified hai, so not modified 30%. So 0.30, okay, multiply with what? Okay, 8 milliseconds. So this is the case whenever the phase fault occurs. And when there is no phase fault, what is the formula? When there is no phase fault, 1 minus p into m. So when there is no phase fault, that is 1 minus p, multiply with main memory access time. Kitna diya main memory access time? That is 1 milliseconds. Okay, right? And you want effective memory access time as how much here? Okay, not more than 2 milliseconds. So you can take 2 milliseconds. So I think board is visible properly now. So okay, you take this as a 2 milliseconds because effective memory access time you want 2 milliseconds. So P into, okay, in the whenever the phase fault occurs, you are having two cases. Okay, one is a modified case and not modified case. If it is modified case, he is taking different service time, and not modified case, different service time. And when there is no phase fault, you access what? Main memory access time. So you need to derive the formula, okay, sorry, this equation carefully and try to get the answer. So I am writing the answer here. So P value you get as 0.064. 0.064. So right answer is what? Okay, B for Bombay. So B is the right answer. So that is how you need to solve the problem. Is that clear? Right. So let's see the next question. Okay, let's solve the next question. Go to your workbook again. Page number 111, question number 21. Okay, so please try to solve this. So page number 111. Okay, so I am writing the question there. Question number 21. Question number 21. So okay, just listen. 1 minute suno idhar, 1 minute suno. The question is having the TLB, okay, and also effective memory access time and also page fault rate. Okay, TLB is also given to you in this question. So roughly try to make the diagram. Try to make the diagram, and after that you need to derive your own equation. Is that clear? So our formula, whatever we discussed, it will not work because it is also having effective memory. TLB is added in this. So please try to, okay, draw rough diagram बना के खुद का equation बनाना पड़ेगा. Is that clear? You have to make your own diagram and you have to derive the your own equation. Is that clear? So read the question carefully and sincerely try to solve the problem. Whether it's wrong or right, it doesn't matter. So please try to solve the problem. I'll wait 5 seconds in the live. Okay, so then I will discuss. So I am making the diagram, just a rough diagram. Let's say we are having CPU always generates logical address. So that is okay, P and D. So let's say you take the page number. So first you refer in the TLB. Okay, if you are solving, just pause my video. Okay, after solving only you continue to watch the video. So okay, first you take the page number and refer in the TLB. So if it is found in the TLB, so that is called as what? TLB hit. So okay, if TLB hit, so then directly you get what? Frame number. Okay, you get the frame number and you make physical address and all that. Okay, so I am not writing all that. Okay, so I make rough diagram, so not required. So okay, F यहाँ से ले लेंगे, यहाँ से TLB से मिलेगा. Okay, directly write. Okay, just rough diagram I am making, so please understand that. So you go to what? PAS. Okay, main memory. And the next, okay, if it is miss in the TLB, now tell me, if it is miss in the TLB, then what happens? Then we go through what? Page table. So you will have a page table here. So you are having page table. So from the page table you get the frame number and then you make a physical address. Okay, so this is the TLB hit ka case ho gaya and this will be the TLB miss. Okay, now understand the question. What is given in the question? Try to understand here. Okay, so I am just reading here. TLB is added. Okay, so page fault service time is 200, that is very clearly given. The main memory access time is 10 milliseconds. TLB, okay, is added to improve the performance, that is also given. The 80% references are found in the TLB. 80% references are found in the TLB and that of the remaining 10% cause the page faults. Understand this point carefully. 80% references are found in the TLB and that of the remaining 10% cause the page fault. इसका मतलब क्या होता है? Okay, so somebody understanding in a wrong way. 80% references are found in the TLB. So now tell me, TLB hit ratio is how much? 80%. So very clear. Remember, TLB hit ratio is 80%. Then obviously TLB miss ratio will be how much? Tell me, 20%. Is that clear? So TLB hit ratio is 80%, then obviously miss ratio will be what? 20%. So 80% differences are found in the TLB, and that of the remaining, okay, it means what? Okay, now TLB hit ratio 20%, so miss ratio will be what? 80%, and that of the remaining 10% cause page fault. So it means from this 20% TLB miss, the 10% are causing page faults. So 10% cause page faults. So this is the, okay, meaning of the question. 10% cause page faults. So this is how, okay, you need to, okay, draw the diagram. Okay, this is the interpretation of the question. Now, so just okay, understand here. Let's try to solve the problem here. Effective memory access time equal to, okay, so I am writing here properly. Later you can copy. First listen here. Effective memory access time equal to, now tell me, first you refer in the TLB. TLB hit ratio is how much here? 0.80, 80%. TLB may hit to tell me, if it is hit in the TLB, then what happens? You are accessing TLB and you will access the main memory access time. Okay, you are accessing TLB and you access the actual page. Okay, so TLB access time is given as what? Negligible. So that is the reason you have to take what? 0. And then you will access what? Okay, actual page. That is the main memory access time. So that is a 10 milliseconds. So I am writing clearly. So this is a TLB hit ratio, and this is a, okay, TLB time. Okay, and this is a main memory access time. Plus, now tell me, so 80% is the TLB hit ratio, then obviously miss ratio will be how much here? 20%. So 0.20. So this is okay, TLB miss. Okay, TLB miss. Okay, now, okay, TLB miss ratio 20%. If it is miss in the TLB, now tell me, okay, if it is miss in the TLB, then what is happening? You are already accessing TLB, so TLB access time will be 0. Okay, so that is okay, TLB time. Okay, and next, okay, now look at here. So if it is missing the TLB, you are already accessing TLB. So if it is missing the TLB, okay, in this 20% TLB miss, in this 20% TLB miss, 20% TLB miss के अंदर 10% causing what? Page faults. In this 20% TLB miss, इसके अंदर, okay, 10% are causing page faults. Look at here. So 20% TLB miss है, and इसके अंदर, inside that 10% cause page fault. So that is 0.10. And if it is a page fault, you apply what? Service time. Okay, now look at it. So this is a page fault rate, and this is a page fault service time plus, okay, so in this 20% TLB miss, 10% causing page fault. So if it is a page fault, okay, you apply service time, and 90% there is no page fault, so that is 0.90. okay, multiply with the main memory access time, that is 10 milliseconds. So that's it. So this is how, okay, you solve the problem. Okay, so this is what here, okay, 90% is what? No page fault, and this 10 millisecond is what? Main memory access time. Is that clear? So understand here, मैं repeat कर रहा हूँ फिर से, whenever is having doubt, 80% is a TLB hit. अगर TLB में hit हो रहा है, you are accessing TLB and you will access actual page. So TLB hit ratio given, TLB access time given as negligible. So that is the reason I am writing 0 here. And okay, look at it, TLB hit हुआ, TLB access किया, main memory access किया. Okay, next 80% TLB miss है, तो TLB miss कितना है? 20%. and TLB miss है, तो क्या हो रहा है? You are already accessing TLB, so that is 0, negligible है. So ये 20% TLB miss के अंदर 10% are having what? Page fault. अगर page fault हो रहा है तो you apply service time, and 10% page fault है तो no page fault is what? 90%. When there is no page fault, you access main memory access time. So that's it. So now you need to derive this okay equation and try to solve that equation and get the answer. So your answer is okay, so I am checking that answer. Answer will be 13.8 milliseconds. So exactly, okay, you can solve that. So that will be 13.8 milliseconds. So please use the calci and all that. So try to apply that in calci and get the answer. 13.8 milliseconds. Okay, so there are the various questions on the effective memory access time. So okay, so low level to high level. Okay, various questions. Right.